How's it going, everybody in Algebra 2 World? As promised, this is the video about solving systems algebraically as far as elimination, substitution, and then we'll look at the three equation system of equations with three variables. We'll get to that in just a little bit though. So with substitution, the biggest thing that you want to have is make sure that you have a variable kind of by itself. So in this, remember with systems that we have a solution that is an xy point, in this case because we have x and y, where both of these values are the same and where they are true for both equations. So with this, if I know that y equals 3x, I can take that y and substitute it in for that y right there, such that I would have the equation 5x plus 2 times 3x, since that's what y is, equals negative 44. Then it's just a matter of solving this, so 5x plus 6x equals negative 44. Then we have 11x equals negative 44, so x equals negative 4 when you divide by 11. So now that I know x is 4, I can take this, substitute it back into either one of these, but it's usually a little bit easier into the one that has less stuff with it. So in order to get the y value, I know that y is 3 times x, and if x is negative 4, then that means y is negative 12. I will write this as our ordered pair solution, negative 4, negative 12. Oh yeah. Woo! All right, look at another one. Same sort of idea. We're going to do substitution again. So here, I do not have a variable by itself in either one of these equations. However, don't forget, you can still add, subtract, multiply, divide just like you always would. So in this one, I notice there's kind of a y that's kind of ish by itself. There's only one y, whereas this would be 2x, 4x, 3y, but this one I could add the y to the other side of the equation such that that would just make it y on that side. It would be y plus 7, but remember we can move that 7 over such that we would have the equation y equals 2x minus 7, and that has gotten the y by itself. So now I can take what that y is, substitute this in for the y in this equation. So I have 4x plus 3 times my y, which is 2x minus 7, equals 9. And then be careful with distribution. Make sure you distribute 3 to both of those. So we have 3 times 2x is 6x. 3 times negative 7 is negative 21. Equals 9 still, and I still have the 4x in front. Go ahead and add your 21 to the other side. Just solving this like you would any other equation at this point. So we have x is 3. Again, once you know your x, you can plug it into either one of these. Both of these will give you the same solution for y. So say we choose the second one. I would choose the second one just because it has less stuff. But again, it doesn't matter. If you choose the first one, you'll still get the same value for y. So if I know x is 3, I can say 2 times 3 minus y equals 7. So this is 6 minus y equals 7. Subtract the 6, so negative y equals 1. So y equals negative 1. So then I have the point 3, negative 1. That's a 1. It's a weird squiggly 1, but it's a 1. Yes, 3, negative 1. That is my solution. Always write as an ordered pair, please. All right, looking at another. This one, we are going to be doing solving by elimination. Elimination is kind of usually my preferred method, but that's just preference. Once you guys get used to these, now that you know how to do graphing, substitution, and elimination, I honestly don't really care how you do them. Just make sure that you do them and whatever you're comfortable with, you do them right. Elimination to me is the easiest, but again, it's just personal preference. So with elimination, you can either essentially eliminate the x's or eliminate the y's. It makes no difference which one you choose. In this case, I would think that eliminating the x's would be easier. So if I multiply this entire equation, what I mean as far as eliminating, if I multiply this equation by negative 4x, that will now create the equation negative 4x minus 12y equals negative 32. If I look at these two equations together and I combine them, 4x minus 4x is 0, so I have essentially eliminated the x's. I'm left with negative 14y equals negative 28. You can divide by negative 14 at that point, and y equals 2. Now that we know what y is, we can take y and substitute into one of our equations. If it were me, I would do it right there. So x plus 3 times 2 equals 8. So it's x plus 6 equals 8. So x must be 2. Write it as an ordered pair. The pretty ballerina wears a tutu. Ha 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 ha. Monkey tutu. Tutu monkey. Alright, look at another. Alright, so one like this. We have negative 3x plus y equals negative 2. Again, I would choose elimination. I know that's what it says, but I would choose it anyways. Oh, sorry. I'm not tired, I promise. So you can eliminate the x's or you can eliminate the y's. So if I multiply by 2, that would give us the equation negative 6x plus 2y equals negative 4. And if I look at these two equations, well, that would give me 0 x's, so I'd eliminate that. Negative 2y plus 2y is 0y. So I have 0 on that side equals negative 6. Well, since 0 doesn't equal negative 6, that is not true. What this means is there's actually no solution to this equation. If we were to get one that had like, if we did all of our math, blah, 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 and we get our systems down to 2 equals 2, or something like that, or 0 equals 0. If you get something that is true, this is true, 2 definitely does equal 2, right? 2 is 2. So if you get something that's true, what that means is there's actually infinitely many solutions. So no matter what you choose for x or y, it will work in your function. It will work in both of them. So remember, from graphing, that is when we would have a line and we would have the exact same line. So all that really means is that no matter where we are on either one of these lines, it works for both of them because they share every single point together. All right, now we're going to start looking at ones with 3 variables. So I'm going to look here first. Let me get some papers. Let me move things around for a second. Hang on, give me a minute. All right, so with this one, notice we have 1, 2, 3, x, y, z, 3 variables, 3 equations. So this one, it looks really daunting at first. It's really not too terrible. There's a process that we go through with these. So the process is I look at these 2 equations, and I look at these 2 equations, and I get rid of a variable. It doesn't matter which one you get rid of. Just choose the same variable and get rid of it all the time. X is good, Y is good, Z is good. It really doesn't matter which one you want to get rid of. Sorry, I made a stray mark over there. It's just a stray mark. I'm not really doing anything. For our sake, I'll just say eliminate Y. We're going to eliminate my Y's all throughout. So if I take the first 2 equations and I take the second 2 equations, I'll set that up real quick. That's what it would look like setting up both of those equations. So again, notice I took the first 2. Those are right there. That's the first 2. And then I took the second 2. I'm going to eliminate y in both of them, and then we'll come out with another pair of equations that we can eliminate something else. So in order to eliminate y in these, this needs to be a 3 right there. So I need to multiply this top equation by 3. So that should be 6x plus 3y plus 3z equals 28. Oh, no, that's not right. 42. 3 times 14 is 42. All right, so then eliminate the y's, and we're left with 5x plus 5z equals 40. Likewise, I'll do the same thing over here. In order to eliminate the y's over here, this would need to be a positive 6 right there. So I will multiply this equation by negative 2. So that will make 2x plus 6y minus 4z equals 4. And I will eliminate the y's. From this point, we have 6x minus z equals negative 1. So we have 2 equations left with 2 variables each. Well, that's what we've been doing earlier in this video. So if I take both of those equations, so 5x plus 5z equals 40, and 6x minus z equals negative 1. We can do elimination, substitution, whatever you want to do from there. From there, it's kind of your choice. I'm going to do elimination, and I'm going to multiply this one by 5 such that it would eliminate my z's. So in doing that, that would turn into, create a divider thing, 5x plus 5z still equals 40. I'm not changing that one. That's just copying the top one down. And then we have 30x minus 5z equals negative 5. Together this will make 35x equals 35. So x must be 1. Cool, we found what one of the variables is. So if I know x is 1, looking right here, that would mean x is 1 right there. So I could substitute a 1 for this x. So if I put in a 1 right here, 5 times 1 is 5, plus 5 times z needs to be 40, so that means z is 7. So I know z is 7. And then if I take both of these and go back to my original equations, you can go all the way up to the top if you want. So 2 times 1 plus y plus 7 needs to be 14. Well, that's 2 plus 7 is 9, so I need 5 more, so y must be 5. Write this in numeric order. Sorry, not numeric order, in alphabet order. So x, y, z, so 1, 5, 7 is your triple ordered pair. This is always in alpha order. All right, I'm going to walk you guys through one more of these. I know they're kind of weird at first. You'll get used to them. I promise. Just keep practicing. All right, here's the next one we're going to look at. Still, again, 3 equations with 3 variables. So I'm going to solve this. I'm going to set up my first 2 together and my second 2 together and pick a variable that I want to eliminate. So here's our equations. Looking at it, it looks like x is going to be the easiest to eliminate because here I can just multiply my bottom equation by negative 2. So that will make that negative 2 and positive 2. And this one I can just multiply my bottom equation by 2. The other ones we'd have to multiply by a little bit more in order to get rid of both of them in either equation. But again, there's no real right or wrong thing to do. Just pick one variable and just make sure you're getting rid of that one variable in both of your equations. That's the only way you can go wrong is if you don't follow that. So if I multiply this one by 2, this is now 4x minus y plus z equals 0, and negative 4x plus 4y plus 6z equals 6. Over here, I'm going to multiply by negative 2. So this is still negative 2x plus 2y plus 3z equals 3. And 2x minus 6y plus 4z equals 38. All right, so in both of those equations, I am able to get rid of x, and I am able to get rid of x. So I'm left with 3y plus 7. That's a 7. That's a 7. Oh, no. That's a 7. 7z equals 6. And I have negative 4y plus 7z. Oh, my gosh, I did it again. Holy cow. That's a 7. Oh, my goodness. 4 and 3. 7z equals 41. I can combine both of these. So I have negative 4y plus 7, don't do it, 7z equals 41. Well, that's easy to get rid of the z's because I can multiply this by negative 1, so that's positive, negative, negative. So I have 7y equals, what is that, negative 35. So that means y is negative 5. Now if I know y is negative 5, I can substitute it into either one of those. Say I do it into this first one here. So that's 3 times negative 5. Oh, I am off the paper. There we go. 3 times negative 5. So I'm substituting it here. Plus 7. Scary. I'm tired of writing 7s. So that's negative 15. Plus 7z equals 6. Add the 15. 7z equals 21. Z is 3. So I know y is negative 5, z is 3. Substitute it into one of your original equations to get what x is. So say I choose this one right here. Again, I know y is negative 5. So I don't know x. Negative x plus 3 times negative 5 minus 2 times z is, where'd it go? 3 equals negative 19. Simplify your numbers. Minus 15 minus 6 equals negative 19. Negative x minus 21 equals negative 19. And then I did 21. So negative x is 2. So x equals negative 2. And write this as a beautiful ordered pair where we have X, Y, Z in order. And it's not an ordered pair, it's an ordered trio. Oh, trio. Alright, hopefully this video has been helpful for you guys. Again, you can make it a monkey if you want to. I'll be happy as long as I'm able to see your point. Alright, I'll see y'all soon. Boop.